Now let's try another type of example, and what's really cool about this is you can do a table of values that works just fine. But if we use some of the properties of an exponential growth function, you can save yourself a lot of work. Okay, so let's kind of look at this first. I have 1/2 times 4 to the x power. That means my a value is 1/2, and my b value is whatever those two multiplied together are. My b value is going to be 1/2 times 4, which is 2. Okay, and that's a little different. The original parent function was in the form y equals b to the x power. You just had one number in front of there. Now we're faced with 2. So to figure out that b value, you would actually multiply them together. Okay, and what's really cool about this is we can get a graph pretty quickly. The first point on your graph has to be on your y-axis, okay? And that parent function, y equals b to the x, there's no other number there. So that y-intercept was 0, 1. Here, we have an a value of 1/2. So our y-intercept is going to be the point 0, 1/2. And I'll kind of write that on the board here. We have 0, your a value. For us, that is the point 0, 1/2. 1 point, done. Next point is 1, and then your b value. And we just figured out our b value is 2. So our next point will be 1, 2. And then from there, we kind of know the general shape of these exponential growth models now, so we can draw a slow curve from left to right. Again, do not cross this x-axis. And we're done. And again, let's put this little note on here that this point is 1, and then your b value. For us, that was 1, 2. Now let's have you guys try b on your own. Remember to pick your a and your b value first. Okay, I hope you guys put some thought into that. It's just like the process of our first one. We first identify our a and our b value. For a, there's no number in there, but there's a negative sign. We know that that phantom one is hiding there. Okay, you guys know we're at school. So we get our a and our b. Our first point on the y-intercept is 0, and then our a value. Our second point is 1, and then our b value. So we should, from left to right, this one's facing down. And I bet you guys know what that is. That negative is going to make us face down. Good job, guys. Okay, so now we are going to graph an exponential function with some translations. And the good thing is that it's in kind of the same spot you guys are used to. So let's start with figuring out that a value and our b value. Our a value is whatever is right in front of that multiplication sign. So we have an a value at 4. Our b value is going to be those two multiplied together. 4 times 2, 8. So right away, I can graph my function without any translations on it. Because we look at our exponent, we see x minus 1, minus 3 at the end. We know there's going to be some movement on that graph. So let's graph our parent function. We're going to call this one the parent because it's going to be where we start. Okay, so remember, our first point, the y-intercept, is 0 for your x and your a value. Here we have an a value of 4. So 1, 2, 3, 4. That's my intercept. Our next one is going to be, and I might need to, no, it'll be good. Our next one is 1, and then our b value. And as you can see, I kind of made my graph too short. I'm going to have to do some erasing here, but that's all good. We'll just move our x-axis down a little bit. We'll go right about there. Okay, so our b value is 1, our next point is 1, and then my b value. Here's 1. And I'm going to go up to 8, and I'm going to have to adjust this a value here. Okay, so what I'm doing right now, I made my graph too high. I have to move it down a little bit. So 1, 2, 3, 4. My intercept is now here. And that should be a 0. There we go. My next point is 1 in my b value. So 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this, and it's kind of hard to see because we've got a really tall graph there, but we would still start it the same way. It starts really close to the x-axis on the left side. So it would actually come right up this way. Okay, that is my parent function with no translations on it. Now I'm going to worry about the x minus 1 and the negative 3 at the end. And what's really good about this is those are just like all of our other functions. If I have a negative 1 next to x, I'm going to pull the opposite out of there to figure out which way it's moving. Okay, so this one is a x minus 1. Opposite of minus 1 is a plus 1. So I'm going to move, and I'm going to write this over here. X minus 1 means I'm going to move in the positive direction, or to the right, 1 spot. Don't forget to take the opposite. Okay, so I'm going to move every point, and I only have 2, so it's super easy, to the right 1 spot. Now, look at that negative 3 there. If you guys will remember, when we graphed other functions, if we had a negative 3 at the end, everything moved down. And you know what? It's exactly the same thing for this. So because I have a negative 3, I'm going to move down 3. So I'm going to take both of my points here and move them to the right 1, down 3. So right 1, down 3. I am now at, it looks like 2, 5. And I'm going to do the same to this one. Right 1, down 3. I'm at 1, 1. Then I'm going to draw my line, and you'll see that we are going to cross the x-axis here. That's because my asymptote also moves down 3. It doesn't matter if my asymptote moves to the right once. It's a straight line. We're going to take my asymptote and move it down 3. So if you could see it on here, here's my asymptote, the x-axis. It's going to go down 3. 1, 2, 3. So my asymptote technically is right down there now. Okay? So this graph here, we're going to start at the left. It's getting really close to that asymptote. We can't go across it. And drop.